Hello everyone, I am Manya, currently pursuing second year BCA in St. Francis de Sales College. Today I am going to explain quicksort, which is a fast sorting technique. This topic is part of my 4th semester BCA course. So first let's understand what sorting is. Sorting means arranging data in a particular order like ascending or descending order. It is very important in many real-life applications like searching and data processing. Quicksort is one of the fastest and most efficient sorting algorithms. It works using a method called divide and conquer strategy. What is a quicksort? Quicksort is a comparison-based sorting algorithm. It works by selecting a pivot element from the array. Then it divides the array into two parts, one with smaller elements and one with the larger elements. After that, the same process is applied again and again to sort the entire array. Definition: Quicksort is a sorting algorithm based on the divide and conquer strategy. It works by selecting a pivot element, partitioning the array around the pivot, and recursively sorting the subarrays. Now let's understand divide and conquer strategy in simple steps. First is divide. Here we choose a pivot and split the array. Second is conquer. We sort the smaller parts recursively. Finally, combine. All the sorted elements are combined at the end. Here, no extra work is needed in quicksort because the array automatically gets sorted. How quicksort works? First, we choose a pivot element, then we place all smaller elements to the left side and all larger elements to the right side. After that, we repeat the small same steps for the left and right subarrays until everything is sorted. Now I'll explain this diagram which shows how quicksort works step by step using the recursion. First, we start with the given array which contains the elements 4, 3, 1, 2, 5, 9, 7, 10 and 6. Here we choose 5 as a pivot element. Now we do partitioning. All the elements which are smaller than 5 are placed to the left part of the array, and all the elements those are larger than 5 are placed at the right part of the array. Now we do partitioning. After the partitioning, we can conclude that the element 5, which is a pivot element, is positioned in the correct order. Next, we apply quicksort recursively to both the sides. On the left side, we have 1, 2, 4 and 3. After partitioning, we get smaller parts like 1 and then 3, 4. We continue this process until each element is sorted individually. Now on the right side we have 6, 7, 10 and 9. When again we choose a pivot which is 6. Then we partition the elements. We continue dividing into smaller parts like 7, 9, 10 and sort them step by step. At each stage, you can see that the array is divided into smaller subarrays and each pivot gets its correct position. This process continues until all elements are sorted. Finally, all the parts combine to form the sorted array, that is 1, 2, 3, 4, 5, 6, 7, 9 and 10. So this diagram clearly shows how quicksort uses partitioning and recursion to sort the array step by step. Now let's look at the algorithm. If the starting index is less than the ending index, we find the partition position of the pivot. Then we apply quicksort on the left part and the right part separately. This process continues until the entire array is sorted. Partition and code for partition. Partition is the most important step in quicksort. Here, the pivot element is placed in its correct position. All smaller elements are moved to the left side and all larger elements are moved to the right side. In the code, we take the last element as the pivot. Then we compare each element and swap when needed. Finally, we place the pivot in its correct position. Time and space complexity. In In the best and average case, quicksort takes n log n time, which is very fast, but in worst case, it takes n square time, which means when the pivot is not chosen properly. And for the space complexity, it's always n log n. And here, no, no extra space is required for the quicksort, which uses very less memory. Advantages and disadvantages. Quicksort has many advantages. It is very fast and efficient. It works well for large datasets and the logic is simple to understand. But it also has some disadvantages too. In the worst case, it becomes slow. Its performance depends on pivot selection and it is not stable, meaning equal elements may not keep their order. Applications. Quicksort is used in many real-world applications. It is used for data sorting, database operations, and searching algorithms. Because of its speed, it is widely used in programming. Conclusion. To conclude, Quicksort is a fast and widely used sorting algorithm. It is based on the divide and conquer technique. It is very efficient, especially for large datasets. Thank you.